So now we're going to talk about measuring in significant figures, how to report the correct number of digits when you're doing measurements, especially like in a lab setting. So the importance of significant figures are that they tell you how precise your measuring tool is. So if you're asked to measure, for example, 16 milliliters of water, and you have a choice between a graduated cylinder that's marked every 10 milliliters, so a 10, 20, 30, versus a graduated cylinder that's marked every 1 milliliter, 1, 2, 3, 4, etc., you're going to be more likely to get an accurate and precise measure of 16 milliliters using the 1 milliliter graduated cylinder versus the 10. So that's what a significant figure tells you. It tells you how precise your measuring tool was. The most common instrument we use this with anymore is graduated cylinders. A lot of our other equipment is electronic. Scales, for example, that measure mass are electronic. The graduated cylinders are pretty much still just tools that we use all the time to measure volume, and they're going to be different. They're going to have a different number of significant figures depending on which graduated cylinder you're using. So you see on the screen here there's 3 different graduated cylinders. So when you measure to significant figures, what you're going to pay attention to is you measure to what it is calibrated to plus what we call a guess or estimated digit. Now, this is all dependent upon the old school, middle school number line. So if we look at this number line, this right here is the thousandth, this is the hundredth, this is the tens, this is the tenths with TH, hundredths, thousandths, etc. and so forth. So when we say, what is this calibrated to? What we're looking at is where on this number line is the device actually marked? Is there an actual mark showing one of these numbers? So if I look at A, the first one, I see a 50 and I see a 60. So it's definitely marked to at least the tens. I see a 50, 60, etc. But if you look in here, I also see 10 smaller hash marks. So if we count, there's actually 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hash marks in between. So what that tells me is each of these smallest hash marks shown represents 1 milliliter. So for example, this would be 51, 52, and as you go up, it just go up by 1, 53, 54, 55. So there is no smaller hash mark than that. So when we say, what is this instrument calibrated to, it is calibrated to the ones, to this place right here. It is calibrated to the 1 digit. So what that means is you can be absolutely certain that to the ones place your measurement is correct. But in order to measure in the correct number of significant figures, you're not only taking it to what it's calibrated to, but you're adding that guess digit. So your guess digit is your estimate. You're kind of estimating about where is it hitting. Is it hitting exactly at the 1, or is it a 0.5, halfway between, quarter between, those kind of things. You would not add 2 decimal places because that's adding 2 guesses. You only add 1 guess place. So again, it's what it's calibrated to, what it is physically marked on the instrument. The smallest place plus the next place over, plus a guess digit. So in this case, again, we are marked to the single digit, to the 10th, to the single. You're adding the guess digit of the 10th place. So your answer should have 1 decimal point. So if I look at my digit here, here is my line. Remember, it's a meniscus. You always measure to the bottom of a meniscus. So when I look at this, I see it's pretty darn close to being exactly on that line there. So the way I'm going to report this measurement is I'm going to count 51, 52, 53, 54, 55. This would be the 56 mark here. Now because I'm going to say that that's pretty much dead on, the bottom of the meniscus is dead on the 56, I'm going to report my measurement as 56. That's what it's calibrated or marked to. But in order to be the correct number of sig figs, I have to add the 10th decimal place. Because I think it's right on the line, I'm going to put a 0. If you think it's a little bit above the line, you could put a 0.1. 0.2, those kind of things. Sometimes it's not as important that you get exactly, for example, in a quiz or a test, what the instrument's showing. If you had 56.1 there, most likely you would get full credit as long as you had the correct number of decimal places. When you're practicing measuring significant figures, most of the time it's more important that you have the right number of decimal places, and you can be a little bit off on your measurement. So let's look at the next one here. Next one here, I see a 3, and I see a 4, and again I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small hash marks in between the 3 and 4. So if you're looking, if there's 10 places between the 3 and the 4, each of these smallest hash marks actually must be a tenth here. So this must be 3.1. The next one is 3.2, 3.3, 3.4, all the way up. So the smallest hash mark here is a little bit different in our number scale. Let's get a different color. This one's actually calibrated to that 10th place. It's calibrated to the first decimal. Calibrated, remember, it means it's showing that decimal place right here. These lines here are showing the 10th place. So it is calibrated to the 10th, which means my guess digit would actually be the 100th place. So this one's going to have 2 decimal places as my answer. So I look again, here's my line here, and I want to measure to the bottom of the meniscus. So I'm going to say this is 4.1, 4.2, 4.3. So it at least reaches 4.3. And then I'm saying this is kind of right between the 4.3 and 4.4, the bottom of the meniscus there. It's kind of in the middle. So that means my answer is going to be 4.3. That is what it's calibrated to, what it's marked to. And then my guess digit, I'm going to say it's not dead on the line. It's not all the way up to the 0.4. I think it's in the middle. So if you want to say something's in the middle, you just put a 5. So my answer there is 4.35 milliliters. This 5 is the guess. I'm not totally sure that it's halfway. It could be 6. The answer could be 4.36. But that's my guess. Still would get credit on that one. And then the last one here, I see a 20 and a 30. 10 in between again. So just like the first one, this is representing 21, 22, 23. So each of the smallest calibration points, again, is representing the ones like we did for the first time. So if it's marked to the 1 place, the first place there, my guess digit would be to the 10th. It's marked to the ones. I can be sure that it is at least 21, 22, 23. It's at least 23. There's my sure thing. That's what it's calibrated to. And then my guess, here's the bottom of the meniscus. I think that one's a little bit above 0.5, so I'm going to put 23.6. Here's my guess digit. If you put 23.5, that's a good guess too.